In this video tutorial, we are going to be solving equations with rational exponents and thereafter uncover the meaning of a to the power of m divided by n. Now, just before we get started with solving equations with rational exponents, we need to first understand what a rational exponent is. In simple terms, we can say that a rational exponent is an exponent which can be written in the form of a fraction. For example, if you have 2 to the power of 1 divided by 2, we refer to this expression right here as a rational exponent. Why? Because this guy over here can be written in the form of a fraction. So in general, we can say that anything written in the form of a to the power of m divided by n is a rational exponent. Okay. Now, there's another property of rational exponents that you need to know or familiarize yourself with, and that is the fact that rational exponents can be converted to radicals or surds. Now, how do you convert them to surds? It's very easy. For example, if you have a to the power of m divided by n, that can be written as a to the power of m root n. Now, what you do here is you drop the base, which is a, and then you raise it to the numerator, which is m in this case, and then you root it by n, which is the denominator. So that's how simple you can actually convert a rational exponent to a radical. So in a case whereby you have 2 to the power of 1 divided by 2, it's the same principle. What you do is you drop the base, which is 2, and then you raise it to the numerator and root that by the denominator. So in this case, it'll be 2 to the power of 1 root 2. So that's how simple you can actually convert a rational exponent to a surd. Okay, so now that we've actually uncovered the denotation of rational exponents, I think it's about time now we actually solve equations with rational exponents. Alright, now just to give you an insight on what will be required of you when you solve equations with rational exponents, I got a few tips for you. First off, you need to know that whenever you're working with rational exponents, you're going to be working with an unknown base. Alright, and your main objective is to actually make that base to be the subject of the formula. So in order for you to be able to do so, you're gonna have to first start off by multiplying the exponent with its reciprocal. That will ensure that the base has an exponent of 1. Alright, and then you need to take note that whatever that you do on the left hand side of the equation, you need to do it on the, or whatever that you do on the left hand side of the equation, you need to do it on the right hand side so that the equation can be balanced. Alright, and then lastly, if the rational exponent has a coefficient, you can divide the entire equation with that coefficient and solve the unknown base or variable. Okay, so those are the few tips that I can actually give you right now. Let's just put them into practice and see how we can apply them. Alright, the first example here is x to the power of 5 divided by 3 equal to 32. Now take note that the base is actually a variable, and now that the base is actually a variable, our main objective is to actually make it to be the subject of the formula. So the only way of doing that is to first start off by multiplying the exponent with its reciprocal. So that will be x to the power of 5 divided by 3 multiplied by 3 divided by 5 equal to 32. But 32 is going to be raised to the power of 3 divided by 5 there. Alright, now take note that I multiply the exponent on either side of the equation with 3 over 5. Why? Because whatever that I do on the left hand side of the equation, I need to do it on the right hand side of the equation so that the equation can be balanced. And I also multiply this exponent with its reciprocal so that we can land up with an exponent of 1 there. Alright, so 5 will cancel 5, 3 will cancel 3, and then we will remain with x the, if you think about it, so it'll be x. And then 32 is the same as 2 to the power of 5, and then we raised it to the exponent of 3 divided by 5. Now from here 5 will cancel 5, and then we'll remain with 2 to the power of 3. Now what is 2 to the power of 3? That is going to give us 8 there. So that's our final answer for this equation, or for this question. So it will be 8 there. Okay, so now in a case whereby you have a rational exponent which is a coefficient, what you can do in that situation, you can divide by that coefficient throughout the entire equation. Alright, so in this case, dividing the left hand side with 2 will leave us with x to the power of 3 divided by 2, and then on the right hand side of the equation, dividing 54 by 2 will actually give us 27 there, if you think about it. And then from here we can multiply the exponent with its reciprocal, so it will be x to the power of 3 divided by 2. Alright, so it will be 3 divided by 2 multiplied by 2 over 3. And then on the right hand side, 27 can be written as 3 to the power of 3 there, and then we can raise that to the reciprocal, so it will be 2 over 3. And then from here things will start to cancel. 3 will cancel 3, 2 will cancel 2, and then we are going to remain with x to the power of 1 there. And then on the right hand side, 3 will cancel 3, and then we will remain with 3 to the power of 2, and then 3 to the 2 will give us 9 there, if you think about it. So that's the final answer for this question. In most cases, when you solve equations with rational exponents, you're gonna end up with 2 answers there. Alright, like in this case here, you'll see as we solve this example that we are actually going to land up with 2 answers. So the first thing to do in order to solve this equation, we are going to multiply the exponent with its reciprocal, so it will be x to the power of 2 multiplied by 1 over 2 equal to 9 can be written as 3 to the power of 2, and then we'll raise it to the reciprocal there of 1 over 2, so that will be 1 over 2. And then from here 2 will cancel 2, and then we will remain with x to the power of 1 on the left hand side there. Okay, and then you need to take note that this can actually be written as plus or minus, meaning that there is going to be 2 answers for this equation. Okay, and then from here 2 will cancel 2, and then we will remain with 3 to the power of 1 there. So our final answer will be plus or minus 3 to the power of 1 there. Okay, so x is actually equal to negative 3, or x is equal to positive 3 there. Okay, now for those of you who may be confused as to why all of a sudden we get 2 solutions, where there's all along we've been getting 1 solution for each problem, well, here's why. If we really had this problem right here, what we could do in order to simplify it, or rather solve it, we could transpose 9 to the left hand side of the equation. That will leave us with x squared minus 9 equal to 0. And then from here we can factorize this equation because we have the difference of 2 squares. So the factors of x squared is actually x and x, and then the factors of 9 is 3 and 3. And then now that we're dealing with the difference of 2 squares, the signs are going to be different. And then the solution for this problem will be x equal to negative 3, or x equal to positive 3 there. So that's the reason why we actually landed up with two solutions for this problem. Alright, so with all of the theories that we've covered in this lesson, I think it's about time now you should actually put it into practice. And in order for you to be able to do that, I left the questions on the description there. You can check them out, click them, download them, and attempt them. Alright, so don't forget to also subscribe to this channel. Until next time, goodbye.